Hello everyone. My name is Daichi, and I will give you a lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is Kinds of Radiation and Their Characteristics, Volume 3. Are you ready? Okay, so far, amongst a lot of kinds of radiation, especially alpha ray, beta ray, and gamma ray have been covered, and their different approaches for ionization have been explained. In addition, in the previous lecture, penetration power and energy of alpha ray were covered.
Yes, thank you for reminding me of that. So today we will learn penetration power and energy of the rest of kinds of radiation, that is, beta ray and gamma ray, right?
Correct. Let's get straight to each kind radiation in sequence. First of all, beta ray. A beta particle has much less mass compared with an alpha particle. Therefore, it travels faster than an alpha particle when considering a particle with almost the same energy. Size of materials which it collides, however, is almost same, and it is also often flicked out. Therefore, it travels in a zigzag manner. Moreover, it has less charge compared with an alpha particle. So, it has less opportunities to react with other surrounding atoms, and consequently, it can travel farther than an alpha particle. But, even so, as a result of collisions with other surrounding materials, in due course it loses its energy, and stops traveling. Regarding the beta particle, as is the case with the alpha particle, each particle has its own specific energy, determined by the kinds of radionuclides, which emit beta ray. Its distribution pattern is, however, different from the alpha particle. It is a mountain-like continuous spectrum, with a single, or multiple peaks, specific to each radionuclide, which emits beta particles. For example, hydrogen-3, also called tritium, which was covered in another lecture, emits a beta particle with energy of 0.0186 MeV. As another example, Cesium-137, one of the radionuclides, which causes impact after an accident of a nuclear power plant, emits a couple of kinds of beta rays. The dominant beta ray has energy of 0.514 MeV, larger energy than tritium. This is also an example which was covered earlier, but iodine-131, which is also used for treatment of thyroid cancer, emits a couple of beta rays. A main beta ray emitted has energy of 0.606 MeV, slightly larger energy than Cesium-137.
The distribution pattern is different, but as is the case with alpha rays, beta rays have various level of energy, which is determined by each kind of radionuclide.
And at last, let me elaborate gamma ray. Gamma ray is electromagnetic wave, therefore, it travels space, almost as fast as light, and much faster than alpha ray. Gamma ray, sometimes itself disappears, by giving energy to other orbit electrons. It travels space, sometimes by interacting with other atoms, that leads to generation of secondary electrons. Therefore, sometimes it doesn't travel straight. In addition, its penetration power is very strong, so, it travels space farther than alpha ray and beta ray. Moreover, as is the case with alpha ray and beta ray, each gamma ray has its own specific energy, depending on kinds of radionuclides, which emit gamma ray. Further to that, as shown in this figure, as is the case with alpha ray, gamma ray has a single line spectrum, or multiple line spectra, whose pattern is determined by each radionuclide, which emits gamma ray. For example, gamma ray of iridium-192, which is used during non-destructive test, has mainly energy of 0.317 or 0.468 MeV. For the next, although this was already covered during the part of beta ray, Cesium-137 emits gamma ray, with energy of mainly 0.662 MeV, after transforming itself into barium-137. by emitting beta ray. At last, as touched upon in the previous lecture, cobalt-60 is used for insecticidal purpose of foodstuff, as well as for disinfection. And it emits gamma rays, which have mainly energy of 1.173, or 1.332 megaelectronvolt.
I understand that gamma ray travels space in a different manner, compared with alpha ray and beta ray. And penetration power of gamma ray is much stronger than other two kinds of radiation. On the other hand, it has a common point with alpha ray and beta ray, that each ray has own energy, specific to a radionuclide, which emits the ray.
Correct. Then basic characteristics, including penetration power of alpha ray, beta ray, and gamma ray, has been now covered. So, in the next lecture, let us move on to a topic of difference of impact on people's health, caused by each kind of radiation. So, let me wrap up my lecture by providing you the key points. Today I talked about the difference of penetration power, as well as energy of beta ray and gamma ray. First of all, beta ray travels faster than alpha ray, when they have almost same level of energy. A beta particle, however, has almost the same size with the materials with which a beta particle collides. Therefore, it travels in a zigzag manner. In addition, it is smaller and has less charge compared with an alpha particle. So, beta ray has less opportunities to react with other materials and travels farther than alpha ray. Moreover, each beta ray has its own energy, specific to a radionuclide, which emits the beta ray. And its distribution pattern is different from that of alpha ray, but it shows a continuous spectrum. At last, characteristic of gamma ray was covered. Gamma ray is electromagnetic wave, and it travels faster than alpha ray, and almost as fast as light. In addition, it sometimes disappears on its own way, but sometimes it travels in a zigzag manner, by interacting with other materials. Moreover, it has neither mass nor charge, so it has less reactivity, and travels farther than alpha ray and beta ray. And each gamma ray has its own energy, with a single line spectrum, or multiple spectra, specific to each radionuclide, which emits gamma ray. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.